So welcome everybody to the kickoff for the GPM-GLOBE Precipitation Student Field Campaign. So given that we are talking about weather today, if we can have put in the chat window what your location is and what your weather's like today, and if you're watching this as a recording, you can just kind of shout out what the weather's like in your location. I'm at NASA Goddard Space Flight Center in Greenbelt, Maryland, and we've got it's about 44 degrees Fahrenheit, 7 Celsius, and we had rain this morning, but it's no more rain, at least here right now. So yes, we are talking about precipitation. So let me introduce myself. My name is Kristen Weaver. I'm an education specialist for the Global Precipitation Measurement Mission. And so what I'm going to do today is tell you a little bit about the GPM mission and why we need to do ground validation and look at precipitation data both from the ground and from space, and a little bit about how you can be involved with this field campaign. So first of all, when you see NASA, what does that make you think of? Maybe just throw in the chat window, or again, those of you watching this as a recording, just throw out some things. What do you think of when you see NASA? So some things, I saw astronauts there, space shuttles sometimes people think of, stars, galaxies, planets, and NASA certainly studies all those things, but NASA also studies this planet, our very own planet Earth. And so the mission that you'll be helping do some student ground validation for is one of those missions that's studying Earth. And if we look at Earth, it looks like there's a whole lot of water available there. We can see, lots of blue, there's some clouds and all sorts of water, it looks like. However, when you think about that water, it turns out not that much of it is actually really usable by humans. Only about 1% is actually really usable by humans. So, even though it looks like we have this beautiful blue Earth, a lot of that is not actually really very accessible to us. So if we break it down even further, you can see there, a lot of the places where water is stored, a lot of it in groundwater, a lot of it in ice caps. And then, when we're looking at precipitation for this mission, we've also got this little bit of water that's in the atmosphere as precipitation, and that's one of the things that we want to monitor. So because water is so scarce a resource, that's why we need to really track it throughout the water cycle. And including what this mission looks at is that part of the water cycle called precipitation, falling rain and snow. So the easiest way to measure rain is the rain gauges like you guys have outside your school, just a cylinder with some markings, and you put it out and you look at it periodically and see how much rain has fallen. But unfortunately, there aren't really a lot of rain gauges around. So if you see those yellow dots on the left-hand side, there's a lot of gaps in between where we don't have a lot of rain gauges. In fact, if we took all of the rain gauges, the official rain gauges from around the world and put them all in one place, they'd only actually fill up about 2 basketball courts. So, you can see there, that's not actually a lot of coverage. And you might say, well, what about radar? On the news, they always show the radar image. Well, unfortunately, that still doesn't actually cover everywhere. Even in the US that has a pretty good network, we still have some gaps, and it doesn't go out very far over the oceans. So we need something more. And that's where we get into looking from space. So this is the GPM Core Observatory that they built. Pieces of it were built in Japan and around the US, and then they assembled it right here at Goddard Space Flight Center in Greenbelt, Maryland, and it launched last February, almost exactly a year ago. And so the 2 instruments we have there, we've got a microwave imager. You can see that arrow pointing towards those red areas. Those are showing where there's heavy precipitation from this typhoon Makala. This was from January 14th of 2015. So we can get total precipitation using that microwave imager, but GPM is also really cool because it actually has a precipitation radar, one of the only 2 precipitation radars in space that can actually get us 3-dimensional images inside the storm cloud. So not only can we see total precipitation amounts, but we can see whether that precipitation is rain at the top, or rain at the bottom and snow at the top, and where the layer is, where it starts to change between those. So we really have a lot of really neat information that we can get from a satellite. But you can't, just like you can't just rely on rain gauges, you can't just rely on satellites. You actually have to compare the data. Oh, actually, so I have a picture here showing some of the other instruments that you need to support the scientific instruments. Of course, we need solar panels so that we can power our satellite. You need a propulsion module, reaction wheels. That's how they move the satellite around and adjust its orbit as needed. The avionics and star trackers, that's how they know where they are in space so that the engineers can move the satellite to the right place. And then, of course, you need an antenna to send to get instructions from the ground, but also to send your data back. So these are kind of the systems that we need, although what we're interested in is coming from the radar and the microwave imager, but we need all these other supporting systems. So the way satellites look at precipitation is a little bit different than the way we see it on the ground. And since what we're really interested in is what's happening on the ground, and so that we can use it for weather predictions and things, we have to do what's called ground validation. We have to compare what the satellite is seeing to what is being collected in rain gauges or radar on the ground. So we compare that data using to make sure that the computer programs, the algorithms we use for processing the data are working right. And so that's where you come in. Now, when scientists do these types of ground validation campaigns, they set up an array of rain gauges all in one place. There's a picture of one right there of a set of rain gauges. And then they do a very concentrated time period where they're looking at precipitation. They may have aircraft flying over. They have the instruments on the ground. They have the satellite going overhead. But with the rain gauge at your school, you can actually become part of that ground validation as well. And you'll collect data that'll be put into the GLOBE database, and then scientists working with the GPM mission are going to look at comparing it to other ground-based data, comparing it to the satellite data, comparing to a lot of different data sources, and then seeing kind of how those comparisons are happening, what differences are there. But of course, we don't want the scientists to have all the fun, so that's where you as junior scientists get involved too, and we want you to think about questions that you can answer with your own data or by comparing it to other rain gauges nearby or even across the world, and do your own analysis, and even looking at historic averages. Is this season wetter or drier than usual? So there's a lot of questions that you will be able to answer using the data yourself. And so just some examples of some of the types of data that you and your teacher will be able to explore together and look at how all these patterns of precipitation are happening, as well as what's happening in your local area. And finally, the big picture idea here is that it's not just about precipitation in your location. There's a bigger picture about how does this affect people. Is there flooding or landslide occurring? We can put this data in for weather and climate modeling so that you can know if there's going to be a snow day or not. And then we have to look at whether there's enough fresh water available, or if we're having problems with not enough for people to drink or to plant crops and all those sorts of things. And of course, extreme events like hurricanes and snowstorms. So this precipitation data is really valuable and used for all of those things. And really at the heart of it is that we all live on Earth, and we need to understand what's happening on Earth as the Earth is changing. And so NASA's mission is to not just look outside of Earth and look at space and the stars, but also to look at our very own planet Earth and how things are happening on Earth right now. All these things that can affect us: drought, flooding. This is why precipitation matters. So then if we have some questions we have Dr. Mark Cooley here, who studies snow with GPM, and also my education specialist Dorian Janney, also with GPM, and then if there are any questions. So the question is, how big is the GPM satellite? I don't remember the numbers off the top of my head, but the size has been compared to about the size of like a small, well, it's the weight of a small passenger jet. It's a small passenger jet, but it's kind of squished into the size of a truck. So it's pretty big. It's actually the largest satellite ever built at Goddard Space Flight Center. So it's pretty big. And then the next question was how many schools are involved? Well, and that actually, we've had lots of schools have interest in this. So we've had schools that are going to be reporting data from Croatia, from the Dominican Republic, from Puerto Rico, from all over the U.S., from Poland. So as far as actual numbers, part of that will be determined once we start reporting data and we see how many schools are actually sending in data. Oh, Thailand, we've had some from Thailand as well, express interest. So it really is, I think it's to be determined is the answer to that. The question about how often are measurements recorded? So ideally you would record measurements every day, but of course things happen. You have a snow day. If you have a snow day on weekends, you can report a multi-day accumulation. So say you're recording over a weekend, you have your rain gauge out there on Friday, then on Monday you would just report that there have been 3 days of accumulation since the last time you measured you measured the precipitation. So you can do multi-day accumulations. That works for snow days as well, or if it's just that you have the day off school because it's a holiday. So is this the first year that you're taking measurements? Well, GLOBE has been doing precipitation measurements for a long time, but the GPM satellite just launched last year. So this is the first time we've done a GPM-GLOBE Student Field Campaign. And the GPM satellite has been taking measurements since last January 27th of 2014 when it launched. But even before that, there was a satellite that came before it called the Tropical Rainfall Measuring Mission that has been up in space since 1997. So it's been collecting and is still up there. It's nearing the end of its lifespan, but it's still up there. So in terms of satellite, that data has been being collected for a long time. And so as for next year, I think we'd love to do it again next year. I think that also, so far it seems to be going well, but we'll to be determined. And as far as which scientists using this data, we have Dr. Cooley here. He can talk about how he uses the GPM data for a little bit.
Yeah, there's a whole wide range of scientists who use this data. There are people like me who are actually trying to improve the actual quantitative precipitation estimates from GPM data and trying to map up precipitation. But then there are a lot of other scientists who do this on more of an applied research, kind of landslides, crops, water resources around the world. I think we're actually getting some leverage from social scientists as well as another kind of interesting buy-in or side research avenue to GPM data. So there are the hardcore, more atmospheric science scientists like myself, but I think there's a very diverse scientific audience out there who's, I think, finally learning about GPM and what it can actually do for them. I'm kind of excited to kind of link in with these other communities as well.
Well, and to me, it's always interesting that they launch a satellite for some particular purpose to measure something in a particular way, but then it seems like they always find, oh, well, we can actually use this data in other ways. That's kind of that's a neat thing about science that you get you plan for one thing, but you also get some other unexpected results and uses. So then another question there, how long is the lifespan of a satellite? Well, normally they plan these for at least 3 to 5 years. Like the basic mission is 3 years and then it can extend to 5. But the truth is that a lot of these satellites will last longer than that. So the TRIM satellite that I mentioned, it had the same lifespan when it was launched in 1997, but we're at, what, 17, almost 18 years later, and it's still operating. So you know, they plan for a certain lifespan, but then they often stay up longer than initially planned. Has something already been discovered by one of the scientists? Do you have any thoughts on that?
Yeah, I haven't seen anything new and compelling yet. This data set is so brand new. It actually takes many months for the data to be kind of released formally. So I usually expect after the satellite's been up for about a year and a half, that's when you really start seeing the new discoveries kind of trickle out. I think a lot of the new discoveries we'll see from GPM will be for higher latitude precipitation, which we've never had a sensor like this before at higher latitudes. And there's always a lot of interesting things happening in the hurricane research department. Like the Tropical Rainfall Measuring Mission was fantastic for new seminal research with tropical storms. I think GPM will contribute to that as well.
Well, and one important thing that TRIM was able to show was by that precipitation radar that can see inside the storm clouds, it can see something called hot towers, which are convective towers where there's warm air with a lot of moisture rising up, that if you see these hot towers, it can indicate the storm might intensify. And a really good example of that is there's some neat TRIM images of Hurricane Katrina right before it made landfall in the Gulf Coast, and you can see these hot towers, and sure enough, the hurricane intensified. So that's one of the, because TRIM was the first precipitation radar in space, it was able to observe some of these things. But of course, as Dr. Kulie was saying, you know, that TRIM launched in 1997, so some of those discoveries may take a few years after, since GPM's only been around a year. We don't really know what the new big thing is going to be, because we don't have enough time. There hasn't been enough time to process all the data. So then it looks like we have a question about what happens when the satellite dies. That's a popular one. So because it's such a big satellite, they have to actually make sure that they reserve enough fuel that when its lifespan is over, they can actually adjust its orbit so that it'll crash into the ocean. Now, most of the satellite will still probably burn up in the atmosphere just from the friction in the atmosphere, but they are pretty careful about making sure that for a big satellite like this, that they can direct it to land in the ocean. And yes, I'm sure the next follow-up question that I always get from kids is, well, what about all the fish and the animals and things? It is conceivable there could be some small effect on them, but you know, you really would rather have it land in the ocean with pretty minimal effect to a few fish that might be startled nearby, but probably not going to cause a big problem. Whereas if it landed on land on somebody's house, they'd be pretty unhappy about that. So. Do they pick up the pieces? You know, that's actually, I don't know that they do. I think that they just let them, do you know, Dr. Cooley? I don't think they do.
I've not heard anything on this, and I know that TRIM will be undergoing this re-entry soon, so that's where we can actually answer this question.
Yeah, but this is a very popular question once we talk about talk about the lifespan. So I don't know, and I'm pretty sure that, you know, even if they did pick up the pieces, they're going to be in pretty bad shape. They're not going to be able to reuse them for anything. So any other last questions? Well, thank you for tuning in, and thank you for Dr. Cooley and Dorian for joining in, and welcome to the GPM-GLOBE Student Precipitation Campaign.